Today I'm going to tell you guys a little bit about work we're doing at OLCF regarding building a workflows ecosystem for one of the largest climate data sets in the world. So we start with what is the Earth Systems Grid Federation, or ESGF. Basically, it's a giant multi-institution data store of all sorts of climate data. It's used by scientists all over the world to investigate the consequences of climate change scenarios or system feedback, and it's used in a whole multitude of things. It's enormous. It's CMIP5, the Climate Model Intercomparison Project data set was 5 petabytes. We're on CMIP6, which is 20 petabytes, and CMIP7, over 100 petabytes. So it's growing and growing and growing. Massive and tough to do science over. And so one thing we want to be able to do is enable people to build, run, and execute, explore this ESGF, build models and computations over this ESGF data, in which, for example, I took this slide before us, but like if you're a scientist, you want to find new data, code, and papers relevant to your research project. You want to pull them all down in an easy Jupyter format. You want to find these data that are relevant to the types of things you want to do. You want to run these automated workflows over them, et cetera, et cetera, et cetera. The idea is you should be able to build any workflow you want for ESGF data. And so what is a computational workflow? This is a light talk, there's no time for that. But just to kind of put it into context, we have all of these boxes, right? We want to initiate an experiment, we want to filter the data, we want to move it to a computer, we want to post-process it, we want to publish it. It's kind of the mix and matches of all of these boxes together to do whatever science, tell whatever science story you want to tell. And the hard part is letting people rearrange these boxes whatever fashion, right? And so, for example, we think systems like Parsl and Globus Flows. Clearly, there's some powerful avenues there to use to build these. And so, to start this conversation, we talked about our integrated research infrastructure initiative at OLRNL. And what that means, it's a very buzzwordy phrase, but in a nutshell, it means the DOE is big and spread out. Research is becoming autonomous. Let's connect all of our computers and microscopes and storage and make everything automatable. And we care a lot about AI, right? Because those are most of our primary driving use cases now. It's other than simulation. And so here on the right-hand side of the screen, you'll see our computing test bed at Oak Ridge. So I'm part of a project that's called Intersect, which is our contribution to this multi-lab connected ecosystem. And so, we work on projects all the way from, the hardware level at the bottom of this diagram up to services that allow these things to interconnect, all the way up to the application that the users use cases. If you look up at the very top, there's all sorts of pilot projects that are these general domain projects that people want to be able to compute over. They all have an acronym for some reason. But the idea is these are the things we want to enable people to run workflows. And so just to quickly take a glance at our ACE testbed, this is our IRI vision, test things out across all sorts of different computers with all sorts of different architectures. But the idea is it's this big sandbox of Kubernetes and high-performance computing infrastructure that is meant to kind of be interconnected to data streams, to file transfers like this. Kind of all of the work I discussed in this context from the perspective. And so on this testbed, we are enabling support technologies. Foremost is our facility API, which looks a lot like the super facility API, and that we want to provide these highly secure automated connections to our Slurm-based batch systems. Like any API docs you see. But we also want to support, other actors' tools. So such as Globus Compute. I want to be able to run many tasks very easily on these different infrastructure machines. Globus have to be built for that because of Parsl provider infrastructure. And Globus Flows, can I empower this cross-facility work because all of these different organizations are not Oak Ridge, NERSC, all support Globus capabilities. And so when I say support, we're starting from the ground level here. We initiate people being able to even use these tools in the first place. We convince the site leaders to allow us to Globus Flows. Now that we have that, we're going to create these documentations. So here's just some initial work we've done in collaboration with Ryan Tart at Argonne to do some work on OLCF using ESGF that is cross-facility engagement. So for example, we can write this workflow that searches for data, identifies the location of Eagle, which is Argonne's file system, and downloads the data via HTTPS to our ACE testbed. Our ACE testbed, which is adjacent to Frontier, allows us to launch Globus compute functions, do all sorts of things, whatever we want to be able to do. We can create visualizations. We can do whatever. It's a Globus function or Globus compute function. Write whatever you want, deploy it wherever. And then transfer visualization to the cloud and use Globus. So the idea is that this capability just demonstrates that we can transfer data into operation and transfer data out. So this allows us to be so you can computing with so this is actually on the right here, you'll see
very visible on laptop screen is the Globus Flows.
And so the story is that the story is just starting, and we are working very hard to enable all these capabilities, build documentation and examples and communities, and working with as many people as we can, especially on these ESGF data and building workflows over them. I have folks here that are equally contributing to this work. And I will, if you're looking for performance graphs and cool things about climate data, I'll point you to my colleague Kuya Kurihana's talk tomorrow.